Hi, this video is going to be about solving trigonomic equations. So for the first type of equation, this could be like a possible exam question they could give you. So it's this. And you might be wondering, how am I supposed to solve this? There's both cosine and sine, and there's a square. So first of all, when you see this portion of it, I want you to think immediately to the trigonomic identity. Sine square x plus cosine square x equals 1. So in this case, they just rearranged it, put the cosine square here, and then you're just left with the sine square. So then we can resubstitute it. So it's going to be 3 sine square x plus 6 sine x plus 9 equals 0. From here, you might be wondering what we can do. So, this is a very common exam question, and the trick here is to almost like substitute a different variable in place of sine x. So you could be like y sub y as sine x. So then you could rewrite it as 3y squared plus 6y plus 9 equals 0. From here, it's quite simple. So you can factorize it quadratically, and then you can get two answers. So let's just say, I haven't worked this out, but if we get the answer y equals to 1, make sure you sub back sine x. So sine x equals 1, x equals sine negative 1, inverse negative 1, which I believe is 90 degrees. And from here, I want you to, because this is the basic angle, go and solve the unit circle and etc. But this kind of substitution is crucial for you to know. So the second type of equation you will need to know to solve for math would be this kind of equation. So it's 5 cosine x plus 2 sine x equals 0. So here, as you can see, there's no cosine square x or anything like that. So you definitely cannot use any trigonomic identities. And so you might be wondering what to do. Well, because it's a cosine and sine. Here, theoretically, you can divide everything by cosine. Because there is one thing that says sine x over cosine x equals tangent x. So in this case, you would do 5 cos x over cosine x plus 2 sine x over cosine x equals 0. That would simplify to 5 plus 2 tan x. And here you can do the normal solving for x and then the unit circle. However, I would really like to emphasize that if the question was with only sine x, so if it was 2 sine square x equals sine x, it would be very wrong to just divide everything by sine x, because in this case, you would be omitting an answer. I will go through this kind of question in the next segment. Okay, the third kind of equation you need to know how to solve will be these kinds. And I said before, some people's instincts may just be to divide by sine x to get 4 sine x plus 2, but that's very wrong. In this situation, what you would want to do is factorize the sine x. So it's 2 sine x and then 2 sine x plus 1. Because in this case, if you just divide by sine x, you'd be omitting this answer, because it would be 2 sine x equals 0 and 2 sine x, I'm sorry, that's quite ugly, sine x plus 1 equals 0, and here you would continue on to find x. For the last main type of trigonomic equations kind of problem would be the solving types. So basically, this is the question, and show that cosec x over 3 equals 4. one thing I would like to bring your attention to is in this kind of question, I would first change the domain. Because as you see here, this is x and this is x over 3. So the new domain would be x over 3 over 2 pi over 3. So that means when you have a principal value of x and you're going around the unit circle, you know when to stop. However, at the end, you would need, in this case, you would need to if you had this, you would need to times both sides by 3 just to get the final value of x. But for some tips for the showing questions, what I would do is firstly, if it's like cosec or cosecant, I will first change it to like sine or cosine. However, if everything's in cosine, sines, and tangents, I would use the rule sine x over cosine x to change everything in terms of sine and cosine and see where you can like factorize, delete like minus, as well as remember your trigonomic identities. Good luck with your final test, and I hope this helped. If you have any questions, feel free to put them in the comment section below. Thank you.